My name is Alvin Wendt. I actually knew Ralph from a long time ago, many years ago, in Las Vegas. But yeah, I started off in accounting and finance, and that role kind of evolved over time. I worked for a lot of giant Fortune 500 type companies in a myriad of different management roles. My current role is I'm a consultant for a company called Robert Half. They're one of the world's leading staffing companies, but they do a lot of management consulting for a lot of big companies that need for what my need is for it, or my niche is within data science field. And that's something that I'm going to be sharing with you guys today, which is a really cool, fascinating field. It's fast growing. It's a well-paid field, and it's something that if you're interested in data in general, like if you're interested in whatever you're interested in, data science has a connection and ways of touching it in some way. And sorry about my pug.
You're good. You're good.
Yeah.
And you should be good to share.
Okay, sounds good. So I'll be sharing my screen real quick. All right. So I made this with Sway. I'm here to talk to you about data science. I'm going to give you a little bit more intro about myself, a little bit more personal, because who is this person talking to you? So right now I'm talking to you out of Nashville, Tennessee. So here's kind of a nice skyline visual of Nashville, Tennessee. This is actually one of the world's largest pedestrian bridges. So there's no cars in it, it's just pedestrians, but it goes even further out to the right. So this is Nashville, my hometown right now. You're located in the United States. It's in Nashville, Tennessee. So it's surrounded by Kentucky. To the south is Alabama. A little bit to the southeast is Georgia, and then Arkansas to the left. So it's kind of considered the South. What Nashville is noticed for, or is known for, they have a really refined sports teams, sports presence for American football, like for the Tennessee Titans, for any football fans, for soccer or football from a European standpoint. The Nashville Sounds, which is their soccer team. They have a Nashville soccer club team, which is really renowned. And then we have a NHL hockey team called the Nashville Predators. But the real thing that they're noted for Nashville is country music. So it's known as like the country music capital of the world. I'm not sure if the sound will play on this, but it's one of those things where this kind of gives you kind of a feel. It's known for Nashville hot chicken, kind of like Southern living, kind of just a musically inclined city. You go downtown, it's just a really cool place if you're really into concerts, there's, festivals, there's concerts, there's all kinds of music. So I just want to give you guys a feel from where I live at. A little bit more about myself though. This is my wife, Alex. She's awesome. She lives here. She actually works at Vanderbilt, which is one of the major colleges here. But the other people that I wanted to, or people, but my other children, I have a dachshund and a pug. So his name's Pogi. He's a pug. And then this is Chaco. I just kind of made this visual. It's nice and fun. But they also keep me company as I do my data science work. But that's a little bit intro of me, just a little bit of my fun side. Because I can be a business side. So this is my business side. So I'm a data scientist. So what is a data scientist, right? Well, to understand what a data scientist is, you have to understand what like everyone knows what a scientist is. It's someone who is in the business of like knowing and understanding science in terms of more like physical and like social sciences. But where does data come into play with that? So data, to understand that, we need to understand what data is. So data is a collective work of facts, numbers, words, measurements, observations, kind of what you see here, that can be processed with computers. As you guys know, and we're using on Zoom right now, technology is continually improving and being better. And with the computing power we have today, we're able to take all this data and derive information out of it, which is really cool and really powerful. Like here's an example of how much data we actually get in a day. The world produces, and I'm not even going to get, so we have what, hundreds, thousands, millions, billions, trillions, and then what, then it gets into the ones I don't know. But this is how much data in terms of bytes of data that is equivalent to, if we had Blu-ray discs, you stack 10 million of them, which is the height of 4 Eiffel Towers, which is crazy. That's just in one day. So as data continues to grow and grow each day, the demand for people to be able to analyze that data and create tools to analyze that data to derive some kind of insights is ever growing. And where does that data come from? Like, here's some examples of where the data comes from. Obviously, social networks, as people continually post and make things on or make posts and have activity on social media, that's all tracked and stored somewhere. Financial data, anytime you buy something on your debit card, anytime you make an online purchase, that's all tracked. Anytime you watch a movie, even Amazon Prime, your Apple Music, even music in Spotify, that's captured. You have the ones on the far left with the data from ERP systems. That's a lot of business related stuff. So if anything in the world of business, they're capturing data. If you look to the right here, the mobile apps data, anytime you use your phone, whether it's your Apple, Android, or what have you, they're capturing some form of data from the form of apps. And then the last thing I want to talk about is a little bit about the Internet of Things. One thing that's be captured is in most of your devices now that people have, like, whether it's like, they have smart refrigerators now. You have your Alexas and your smart light bulbs and your smart, your video games. All of that's tracking data. And the more things we connect to the internet, the more data we're going to be able to enact. So what do we do with that data? So what do I do on a daily basis? So with data, there's a lot of things you can do with it. And I'm going to show you some examples, but I want to show you kind of what those things kind of consist of. So one piece of it is in the form of math. So there's math and statistics are a crucial form of data science. The second part is being able to code and program. So coding and programming is another cross section of data science. And the last thing is being able to storytell. So you need to be able to have you can't just be a coder and a math person in a class or by yourself in isolation. You have to be able to communicate that to other people and work on teams. So here's a nice little Venn diagram of kind of the cross section of those. So you have your math, your software engineering, your programming, coding, and then you have your data science. The other cross section, like data analysts, don't really deal with the coding as much as the data engineer doesn't deal with the communication piece. So these are other careers that you can probably strive for if maybe you're not strong in a communication field, maybe you're not strong in a coding field, but there's options out there. But the data scientist has to use all three of these modalities. One of the things that I do that kind of separates us from it is being able to build predictive models. So with the data all that data that I just talked about, I use that and I'm able to predict and get insights from it to be able to tell stories about it. And I'm going to show you some interesting things right now, just for example's sake. So let me pull up another window right here. So this is one of my buddies. He made the NYC Foodie Verse. So these are the type of things that I make. So here we have like the Foodie Verse where you can kind of track all this information of New York City restaurants and be able to locate. I think he cross-sectioned this with Yelp reviews. So you can be able to look on a map and find out different information about it. Like I'll pull a map up. The map is actually really cool. So here's a map of New York City, or at least the Manhattan Island portion of it. And you can be able to drill in and look at different things. Like here, let's look at this Vanguard wine bar. Let's look at this, Arco Japanese cuisine, see how many likes, what the location, the categories. So being able to take all that data that's just messy and put it into something that is usable to people like you. So being able to create dashboards like this. Another one is, as you guys know, COVID-19 is a huge thing right now. This is a John Hopkins map, but data scientists created this map in terms of cases where you can zoom in and look at, different cases, deaths, and vaccines administered, and being able to track all of this data is done by data scientists. And I'm going to send you the link to all of this so that way you guys can play with this stuff on your own once we get off the call. This is a really fun one. This is called Why Do Dogs? So somebody took all the answers and all the questions for dog search questions and put them into little categories. So for example, if someone says, why do my dog keep doing what? And then you can see like keep attacking other dogs, keep sticking his tongue out, keeps following me. These are like the questions that people kind of grouped into the frequency of the questions asked on Google. So it's pretty interesting. So like you say, like, why do dogs like, let's say eat? And then we can just Actually, like I can't see the ones where it goes to, but I haven't used this tool yet. But it's a really cool tool to basically show like how words can be even something that you capture in terms of data. The next one, I don't know if anybody's a fan of Pokemon, but someone created an application based on all Pokemon stats, which I thought was pretty fascinating. But it's something that you can kind of pull together. So you can kind of pull together its stats, its defense. Um, I think there was what is it? There's another piece to it I had. And you can just play with like the different variations. This one can evolve. And then you can look at the list and you can kind of pull the different Pokemon. You can see their attacks and the damage indicators and the types of attack types within it. So if you want to look at, this is what they call a tree map right here. And the tree map, this reflects a lot of, this kind of shows the bigger the map is, the more likelihood that is to happen, or the bigger percentage of the whole group. So this represents 100%. So if this is 100%, this section represents roughly like, let's say 30, 40% of the data. So it's really cool once you get into this and to be able to interpret it. That's where the math comes into play. There's a couple other things that are visuals that I can show you. These are cool things that we make in data science. And then even a lot of news, like any kind of visuals, we work with visuals all the time. So this is kind of the storytelling part. So with all of that, those were just kind of some of the examples I wanted to run you through. But this is like the fun part of my work. So with all that, I just wanted to show you how to become a data scientist. So how do I make these things? What can I do with all of this stuff? So it's not restricted just to things I showed you. Whatever you're interested, whether it's gaming, whether it's whether it's some kind of business, whether it's you're interested in environmental, whether you're interested in accounting, whatever area you're interested in, there's a place for you in terms of data science. So data science isn't just its own thing. Data science is very malleable or very moldable to whatever you're interested in. So that's a really cool thing about it. So the path to data science. Obviously, you need to have some skills, and these are some of the skills that make a competent data science. You need to have coding and programming skills, usually within Python and R. Those are programming languages. You have statistics and math. And a lot of people get shied away from the statistics and math. It's not as intensive as, say, like an actuary, someone who's really, really, really good at math. You just need to know the basics of statistics. And then as you grow, you'll learn what you need to learn. Then there's people skills. Obviously, the storytelling piece, the communication, and the collaboration and learning. As a data scientist, you're always going to be learning. You're always going to be working on teams, and you're always going to be finding a way to turn that data into something you can communicate and something that's usable to the people you're speaking to. In terms of education for it, there's traditional college university that you could go this route, which is, these are typical majors from people that come from the major universities. But the cool thing about data science is that you don't need to go typically that route to become a data scientist. You can also go through what they call massive open online courses, where you can learn those programming skills and learn those statistics and math skills that are important for hiring managers. A lot of companies, they just need people that know how to code and know how to build these apps that I just showed you, regardless of whether you went to college. The other thing is data science boot camps. There's a lot of data science boot camps around the world, and why I always push for these. This is the route I went for learning data science. But the cool thing is they go from free to like 10 to 15,000 right now, but they also go to the degree where they have these income sharing agreements where like you'll do the program for free and you don't pay them back until you land a job in data science. So that's kind of a cost-effective way of being able to get into data science as well, if like financial is an issue. So there's a lot of different paths too. It's not just traditional college all the way up. There's a few different routes, but yeah, like, and the job growth is tremendous right now. I believe the job growth for data scientists are sorry, let me leave this up. The job growth for data scientists right now over the next 10 years is 29%. So there's going to be a 29% growth in data scientists and the need for it. And because there's a big gap in the market right now for data scientists and data related professionals, they pay really well. So it's easy for a person to find a data science role in terms of like $100,000 US dollars up. Um, like coming out as an entry level position. Sometimes it's lower, but just depending where you're at, um, because of the supply gap. But it's a super fascinating role. I love it. It's really cool to just be able to work with visuals, and I can just use it not just in my work, but in my personal life too. Whatever I'm interested in, whatever data set you can get a hold of, you can apply it. So that's I'll shut up now because I can talk all day. It's one of those things that you lose your breath, you lose your turn in my household in terms of speaking. So I'll give you guys a chance to ask some questions. It's a really good question. So I like the coding language R, but I will say that with a caveat though. Like it's one of those things where in data science, like there's this big fight between Python and R and which one you should do. They both can do each other's. One tool is a lot better at one thing, and R is a lot better at another thing. So I would say, like for example, Python is a natural, like a general coding language. It's not just used for data science. It's used for web development and building websites, and it's used for software engineering and building, different programs and things like that. But it also can do data science work too. For R was built with data science kind of in mind and built off of that. And then everything else built onto it. So like it's kind of the opposite. It's like so R is a data science. I think data R is a little bit better to understand if you know how to do Excel or you kind of know normal spreadsheets. R is the natural, I think the easier one to learn. But I do know that R is one that a lot of businesses and a lot of companies are utilizing in their underlying scaffolding for their products. So like I know Microsoft's a big investment in R right now, but I think you should learn both. I think the more you can learn, not at the same time, but learn one or the other first. I think if you learn Python, R is going to be easy. If you learn R, Python's going to be easy to learn. It's just learning that first language is always the hardest portion of learning the code. But once you have some coding under your belt, learning other languages is easy. Right now, I think the number one demanded language though to learn is SQL, or they call it SQL, or I call it Squirrel, but it's SQL. That's the number one demanded skill from employers right now.